We have learned how to sketch the graph of y equals to ln x. In this example, we need to sketch the graph of y equals to ln x, and on the same diagram, the graphs of each of the following. This is the sketch for y equals to ln x. Y equals to ln of negative x is actually the reflection of the graph y equals to ln x about the y-axis. You can check with some values of x. For the function y equals to ln of negative x, when x equals to negative 1, y is equals to 0. When x equals to negative 2, y is equals to ln 2. When x equals to negative 3, y is equals to ln 3. For the other function of y equals to ln x, when x equals to 1, y is equals to 0. When x equals to 2, y is equals to ln 2. When x equals to 3, y is equals to ln 3. Hence, the two graphs are the reflection of each other about the y-axis, or the two graphs are symmetrical about the y-axis. One way to insert the sketch of y equals to ln negative x in the same diagram is to use your ruler, place it horizontally, such that the relevant points are equal distance from the y-axis. So with a few dots, you'll be able to sketch y equals to ln of negative x in the same diagram, while showing the relationship between the two graphs. If you use small dots to guide your sketching, make sure the small dots cannot be seen after you draw your sketch. We have learned how to sketch the graph of y equals to 3 plus ln x in a single diagram. Remember to leave the x-intercept in the exact form. It can be 1 over e to the power 3 or e to the power negative 3, unless stated otherwise by the question. Draw the graph of the basic logarithmic function first, y equals to ln x. You can check with some values of x that the graph of y equals to 3 plus ln x will be above the graph of y equals to ln x. In fact, for every value of x, will give a difference of 3 in the values of y for each of the function. So the y value of this function will always be 3 more than the other function. To insert the graph of y equals to 3 plus ln x, one way is to place your ruler vertically. If this is 1 cm, this should also be 1 cm, this should also be 1 cm. Because for each of the value of x, the y coordinate is always 3 more than the other graph. So with a few dots, draw your sketch for y equals to 3 plus ln x. After you draw your sketch, the small dots should not be seen anymore. The sketch of y equals to ln x plus 2 was demonstrated in the previous lesson. You can check with some values of x that the graph of y equals to ln x plus 2 will be above the graph of y equals to ln x. You can check whether they will intercept by letting ln x plus 2 to be equals to ln x. By the equality of logarithms, x plus 2 will be equals to x, and that gives us 2 equals to 0, which is a contradiction. Hence, ln x plus 2 cannot be equals to ln x, which means the two graphs will not intercept. For this example, we need to sketch the graph of y equals to e to the power x, and insert in the same diagram the graph of y equals to 1 plus e to the power 2x. The approach to sketch the graph of y equals to 1 plus e to the power 2x on a single diagram is similar to sketching y equals to 2 to the power x plus 1 as demonstrated in the previous lesson. This is the graph of y equals to e to the power x. The graph of y equals to 1 plus e to the power 2x will be above the other graph. Comparing the two exponential functions, the index of this function is twice more than the index of the other function. This means that as x increases, the value of y increases at a much faster rate than the other graph. So, this graph should be steeper than the other graph. This purple curve is a wrong example.